Hello everyone. Today we are going to talk about differentiation. Many students say that it's hard and when they see a question they don't know what to do. So this video will make things simple as possible for you. Let's start here. Find the derivative of each of the following here. How can you get the derivative? Simply, derivative means dy by dx. So other questions I can ask you, find dy by dx for each of the following. Okay, how can we get dy by dx here? You know, dy by dx, simply this power here, you multiply it by the coefficient of the number. What is the coefficient here? 1. So 2 multiply 1 here is 2. Then you subtract 1 from the power to make it x to the power of 1. No need to write that one. And that's it. This is dy by dx for the first one. Okay. Let's take a look at the second one here. If I need to find dy by dx, so again, 5 multiplied by 2 is going to be 10. Then x to the power of what? You subtract 1 from the power, so it's going to be 4. So x to the power of 4. It doesn't really matter if you have many terms because you are going to do the same process in each of them. Here, here, and there. So dy by dx equals 2 multiply 5 is 10, so that's 10. X to the power of 1, no need to write the 1. Here, this x here has a power of 1 over here. So 1 multiply 7, this is going to be 7. X power of 0, because you are subtracting 1. And when it comes to x power of 0, no need to write it at all, so you write just 7. Okay. This 8 here doesn't have any x's. In other words, this 8 is a constant. If you get the derivative of a constant, it's going to be 0 because there is no rate of a change in that, and we'll speak about this in another video. So this derivative of 8 is 0, so this is your final answer. Okay. What about this question here? This question here looks creepy, or you didn't see it before, but actually it's a very common idea. First of all, if you have a fraction, okay, and you have many terms in the numerator here, you will have to divide each term by the denominator. In other words, you will divide 15x power of 5 divided by 3x. Then you divide 6x power of 3 divided by 3x. Okay, you will do that here to make it easier for you to make it a linear, and it will be easier for you to find its derivative. So here 15x power of 5 divide 3x power of 5, 15 divide 3 is 5, and x power of 5 divide x, you subtract power, so it's going to be x power of 4. 6 divide 3 is 2. X power of 3 divided by x is going to be x power of 2, plus 5 over 3, it's just 5 over 3, and then x power of 2 divided by x is going to be x. We are not done. Actually, this is the question, but in a different form. Right now, you will get dy by dx, okay? And dy by dx here, we will do it as we did before. So 4 multiply 5 is 20. X power of 3 plus 4x power of 1 plus 5 over 3, and this is your final answer for this question. Okay, here the relation between derivative and graphs. Okay, as you can see, this is the graph of this equation here. You have 2 points, pay attention to those please, here, this point and that point. These points are the points which the curve is changing its direction. Here it was going up and now he's going down. Here he's going down and now he's going up. These points are called turning points. Turning points or stationary points. Okay. So how many turning points the graph have here? Simply the answer is 2. We have 2 turning points. What is so special about these turning points? In these turning points, if you draw a tangent here, okay, tangent means a straight line which is parallel to, which is touching the curve at one point. Okay, if you draw that tangent, as you can see, it's going to be parallel to x-axis. Parallel to x-axis, which means there is no slope. It's just completely horizontal. If it's horizontal here, so that means the gradient of this line is 0. So, Mr., what is the relation between gradient and derivative? Actually, when you get the derivative of any function, that means you are getting the gradient of the tangent line. So I'm going to say it again because it will be very useful for you later. When you get the derivative of any function, so you are getting the gradient of the tangent line at any point. Okay? And this is the relation between derivative and gradient. So if he is telling us gradient equal 1, so you get the derivative and make it equal 1. If he is telling you gradient equal 5, you get the derivative and make it equal 5. If he is telling you that it's tangent here, I will tell you now how to deal with that. Find an expression for the derived function. So simply here in question B, let's find the derivative of that, dy by dx. So dy by dx here is 6x squared. Okay, this is 3 multiplied 2, then minus 1, plus 6x minus 12. Okay, this is the derived what function. Plus, this is the answer of question B. Find the coordinates of any turning points on the curve and pay attention to that. To get the coordinates, you have to get the value of x first at these points here and there. Then you are going to substitute it in y in the original function to get the value of y. Let's do that step by step. As I told you just 1 minute ago, if you get the derivative here, that means you are getting the gradient. You are getting what? The gradient, okay? And I told you also the gradient of these lines at these turning points is 0. So the gradient of this line, it's a gradient equal what? 0. So gradient equals 0, and the gradient is the same, the derivative. That means the derivative itself equal 0. So let's do that here in question C. We will make our derivative equal 0, and then we will solve the equation to find the values of x. So 6x squared plus 6x minus 12 equals 0. I'm going to divide the whole equation by 6 because I can, and it will make it simple for me to factorize. So x squared plus 6x. No, not 6x here, I'm sorry. X squared plus x minus 2 equals 0. Okay, now let's factorize that here. If you don't know factorization, here you can use mod 5.3, you can get the answer. And here what are we doing is what I'm looking for two numbers, their multiplication is 2 and the difference between them is 1. So it's 2 and 1, and the bigger number here will take the middle sign, so this will be plus and this will be what? Minus. Here x equals negative 2 and here x equals positive 1. Okay, obviously x equal negative 2, so this point here has x equal negative 2 and we need to get the value of y, and this point here has x equal 1 and we need to get the value of y. How can we get the value of y in any of them? We will substitute in the original function, not in the derived function. We will substitute in the original function. Where is that original function? Over here, the original function here. So to get the value of y, so y equals 2 multiply x power of 3, which is negative 2 power of 3, okay, plus 3 multiply negative 2 power of 2, okay, minus minus 12 multiply negative 2 and plus 1. Remember, this is only when x equals what? Negative 2, then you will get the answer of that. After that, you will substitute x with 1, okay, in the same equation, So here y equals 2 and here 1 power of 3 plus 3 1 power of 2 minus 12 multiply 1 plus 1. Okay, here in this one here 2 plus 3 is 5, 5 minus 12 is negative 7 plus 1, so this is going to be negative 6. And here let's do that together here because no calculator available now. So this is 2 multiply negative 8, this is negative 16, okay, plus 12, and here plus 24 plus 1, okay, negative 4, these together are negative 4, plus 24 is going to be 20 plus 1, so this is going to be 21. Now you have to know that the two turning points which we are talking about are negative 2 and 21, and the other point here is 1 and negative 6. Okay, these are the two turning points. So again, what have we done? We got the gradient, we got the derivative. Okay, the derivative is equal to the gradient, and since we are getting turning points or you are getting stationary points, you have to make your derivative equal 0 and solve it to find the value of x. Okay, these are the 2 points. Fine. Determine, pay attention to question D here. Determine the nature of any turning points that you found. What's the meaning of nature? Nature here, he means maximum or minimum. You have to know which one of these is maximum and which one of these is minimum, and you have to justify your answer. Actually, here, by just looking, you know, if y is 21, which means y is high, so this is the maximum. Y here is negative 6, so y is low, this is the minimum. But it cannot consider as a proper justifying. So what are we going to do? Here, pay attention to this. To justify the nature of these points, you will have to get the second derivative. The second derivative is equal to d2y over dx squared. So, Mr., what do you mean by the second derivative? I mean, you will get the equation itself, the equation after being derived, yani the one which you got here, this one, and you will find its derivative. Again, you will get the one you got here, the first derivative, and you will find its derivative again. So our equation was 6, I will write it here, but 6x squared plus 6x minus 12 plus 6x minus 12. This is dy by dx. Let's get the derivative of that. So how can we do that here? It's 2 multiplied by 6, this is going to be 12, and x power of 1, okay, plus you will 6x, when you find the derivative of that is going to be only 6. So, Mr., is that it? Okay, how can we determine the nature from this? Take the value of x's here in the turning points. Okay, so pay attention to this step, please. When you take the values of x's here, when x equal negative 2, I'm going to substitute in the second derivative. And pay attention to that. Because here, the trick is what? If the answer is positive, that means it is a minimum value. If the answer is negative, that means it is a maximum value. Okay, so let's do that. 12, okay, I'm substituting here. Multiply negative 2 plus 6. Here, the answer is this negative 24 is going to be negative 18. Negative 18 is less than 0. If the answer is less than 0, so that's a maximum point. Okay. Let's do the same here with the second point, which is 1. So 12 multiplied by 1 plus 6. Okay. This is going to be positive 18. And positive 18 is greater than 0. So if it's greater than 0, that means this point here is minimum. So you have to make it clear. You have to make it here. What is maximum? Here the point is -2 and 21 is maximum. And here the other point is 1 and -6 is minimum because of that. And the justifying is clear in here. What you just did, the steps you just did is justify how to justify your answer. Okay, this is minimum. Okay, let's take a look at this question here. In this question here, the curve has an equation. Okay, when x equals 2, the gradient of the curve equals 6. Once you see gradient, even without thinking about the question, the first step you have to do is to get the first derivative. You have to get dy by dx. Okay, so in this case, dy by dx equal 3x squared minus 2kx plus 0. Okay, because here 2 multiply k is 2k. He told me when you put x equal 2, the gradient of the curve is 6. Gradient of the curve, which means this expression here, this expression equal 6. Here, let's do that step by step. So 3x squared minus kx equals 6. Then you substitute x with 2. So 3 here, this is 2k here. Okay. So 3 multiplied by 2 power of 2 minus 2k multiply another 2 equals 6. Okay, so 12 minus 4k equals positive 6. And in this case, when you get the answer here, so 4k equals 6. To get the value of k, 4 divide by 4 in both sides. So in this case, k equals 1.5. Remember, he told you show that k is 1.5. So for sure, if you get a different answer, that means you did something wrong. You have to go back and check. Okay. Let's take a look at question B here. Find the coordinates of the two stationary points. As I told you before, stationary points means the gradient is 0. Okay. Again, the gradient is what? Is 0. So you will take whatever you got here. Okay. And you make it equal 0. And don't forget to substitute k with the value given to you. Let's do that. So 3x squared minus 2kx equals 0. Okay, k is 1.5. So 3x squared minus 1.5 multiplied 2 is 3. So 3x equals 0. Now your job now is to get the value of x, the possible values of x. How can you do that? By simplifying this equation and factorizing this equation. Of course, as you can see, these two are divisible by 3. So let's divide the whole equation by 3. So x squared minus x equals 0. How can we factorize this? Of course, the first type of factorization must come to your mind always, not only in this question, is taking x as a common factor. So here it's going to be x minus 1 equals 0. You split it from here, so you have either x equals 0 or x equals 1. Okay, this is not the end. He's asking you to get stationary points. When you need to find points, you have also to get the value of y. So we will go to the original equation here and substitute x once with 0 and once with y. Substitute once with 0, so y equal 1. Okay, substitute x with 1, so it will be y equal 1 minus 1.5. Okay, plus 1, which is equal to 0.5. Which means the two stationary points here are 0 and 1, and the other point is here 1 and 0.5. And that's it for this question.